If you want to use LINQ to datasets, that is with the typed or untyped datasets, there really are the two different scenarios. There's linked to typed datasets. That's really just working with linked objects because you have a class that represents your data. Or linked to untyped datasets, which is a lot more effort. Linked to typed datasets is like linked objects. There's no difference. Linked to untyped datasets requires extra effort because you're really querying over a collection of data row objects in a data table. The problem is, data table doesn't implement IEnumerable, and you can't query unless the object you're querying implements IEnumerable, so this is a problem. Also, fields in an untyped data row aren't known until runtime. So that, too, lends itself a problem because there's no way you can get IntelliSense on fields in an untyped data row because there's no way at design time you can know what's in there. Let's start then with the easier case, using LINQ to typed datasets. Like I said, this is just like working with LINQ to objects. The table adapter fills in the data, and the schema is known at design time because the typed dataset is a class that represents your data. Let's try an example that uses LINQ to typed datasets, and you'll see it's really not much different than what you've seen already. I've already created the Northwind dataset.xsd here, and you'll see this is a schema that defines the structure of my database. It has table adapters and it's got fields. Now, you might wonder, why would I use the data context versus a data set? Remember, the data context works only with SQL Server. This works with lots of different kinds of data. And also, the Northwind dataset.xsd you normally use in a single project, where this could easily be extracted into a middle tier business object. Okay, we've got this type dataset now. We'd like to write code that queries against it. Let's run the code and see what it looks like. Here, we've got to write the code to go fill in the data set using table adapters, and this really is a lot more effort than using the data context. I had to think hard to remember how to do this even. So we create a new instance of that data set and use the products table adapter to, well, create the instance first, and the same with the categories table adapter, and have each of them fill their corresponding table with data. So now we've filled the categories, we've filled the products, and now I'd like to retrieve a list of product name, unit price, and category name from the various tables, categories and products, where the unit price is greater than 50. Now this just works, luckily, because there are relations between the products and categories tables. So we have from product, that's our iterator, in northwinddata.products, we'll iterate through all the products, order by, category ID and product name, where the unit price is greater than 50, and this points out that it doesn't matter which comes first, where or order by. We're going to select an anonymous type, which is the product name, the unit price, and I'll take the category name property of the categories row that corresponds to this product. You can descend through the relations using the categories row property of a product. That's how a typed data set lets you get from one item to its related set of items. So we'll get the category name for the categories row corresponding to this product, and we'll put it into the category name field. We'll make this into a list, so our display results procedure, the override for that, will display it in a grid, and you'll see we end up easily with just those three fields from two different tables from our typed data set. As you can see, this code is no different than doing any other LINQ to object sort of code, because you're really just working with a collection of strongly typed objects. Using LINQ to untyped datasets is possible, and obviously the teams at Microsoft made a lot of effort to make this happen, but it's a lot more effort on your part as well. It's more complex than working with a typed dataset because you're not working with a collection of objects. Well, you are. It's just collections whose schema you don't know. The problem is, first of all, you're querying over a collection of data row objects in a data table, not a specific type of data row in a specific type of data table, just the plain old data row in a data table. And data table doesn't even implement IEnumerable. So how can you work around this? Extension methods solve this problem. Remember, an extension method allows one class to extend the behavior of another. So, the LINQ namespace includes an extension method for the data table class, which doesn't change at all. There's an asEnumerable method, which is an extension method on the data table class, which allows us to retrieve the contents of the data table as an enumerable instance. So you can then query it. So we'll need to call the asEnumerable method of the data table before we can query it using LINQ. Also, the schema is unknown until runtime, so we need some sort of loose typing on field names and types. Now, the two languages handle this differently. Visual Basic uses a bang operator, and C# uses this syntax. Now, the reason I point this out, both for VB and for C# developers, is that this syntax also works similarly in Visual Basic. Visual Basic just has this cool bang operator, which it's had since the beginning of Visual Basic, that allows it to have loose typing on the names of elements of a collection. C# doesn't have this operator, so it requires you to use field, and then in angle brackets, the type of that field. VB would use just parentheses for that type, and then the field name as a string. Not nearly as neat as Visual Basic's bang operator, but either way, you get no IntelliSense. Obviously, there's no IntelliSense because at design time, you don't know the names of the fields. You just have to type them and hope you type them correctly. Let's try an example that demonstrates using LINQ to an untyped dataset. I'll click the LINQ over Datasets button and we'll walk into the procedure which starts by calling the fill dataset procedure. I'll step into that. The fill dataset procedure just fills a single dataset with a single data table. Basic ADO.NET 101 stuff. So we'll create a new dataset, create a new SQL data adapter, getting our connection string from our settings file, and now we'll fill, using our data adapter, that dataset and call the data table customers. And that's pretty much it. We'll return our data set back, and now we have a data set. I could have filled the data table too. I'm just pointing out that I'm using LINQ over datasets, so I should use a data set in my example. The same kind of code works with a data table, believe me. I'll retrieve a reference to that particular data table. I'll call it customer table in my code. And now I'd like to use a LINQ query to retrieve all my customers in the US and display the customer ID and contact name for that customer. Well, remember, the customer table, that is the data table variable, isn't enumerable. So you have to use the asEnumerable extension method to be able to retrieve data using a LINQ query. Now here we have a where clause. We say where c.field, and it's a string type field. That's a generic definition for that field. We give the name of that field equals USA. And we're going to select an anonymous type here with customer ID and contact name, and we'll use again that same syntax to retrieve information from fields in the data row. There's no way around it. This is the kind of code you have to write if you want to use LINQ over an untyped data set. Notice the strings containing the field names. Otherwise, there's no IntelliSense. You just have to know the names of the fields to use this technique. If I continue stepping through the code, we'll loop through each item in that table, displaying the customer ID field and the contact name field in the output. Notice, you do get IntelliSense here. These are strongly typed fields, because when we created our anonymous type, we made fields of these names, and that's why we can use those field names down here. Run at full speed, and we do get our contact name and customer ID fields here in the output. Although it's easier using LINQ to a typed dataset, this code at least proves that you can use LINQ over an untyped dataset if that's the kind of thing you need to do. In building applications, XML provides another common data source. The LINQ goal is to make it easier for you to work with XML data using the new XDocument class. Now, you could always work with XML data using the XML document class, but that was a lot more work. The XDocument class and its friends, XElement, XAttribute, XComment, and so on, make life way easier when working with XML content, especially when you create XML content. In addition, these classes, XDocument, XElement, and so on, are the classes you'll receive when you use LINQ to query XML data. The LINQ query will hand back to you a collection of XElements or XAttributes or whatever. Now, Visual Basic in this area adds some extra features. C# folks, you're on your own. You'll see examples, but Visual Basic does make it easier. It embeds XML data natively within code, so you don't even have to use these classes to build XML content. C# developers will have to build the XML content manually using new instances of the XDocument, XElement, and so on. Visual Basic can just embed XML natively in the code stream. In addition, Visual Basic provides schema-based IntelliSense. If there's schema available, you'll get IntelliSense against your XML as you write the code. In addition, it has descendant and attribute operators, that is, 3 dots and an @ sign, making the code a little bit more readable than the corresponding C# code. There's nothing you can't do in C# that you can also do in VB. It's just that Visual Basic makes it a little easier using these new features that are LINQ to XML specific. We'll look at examples that show off creating, querying, and modifying XML content using language-specific features. I'll click the LINQ over XML button and we'll step into code, which allows us to create an XML document. Notice I've declared the return value of this procedure using the var keyword. Doc right now is null, but if we step into this, you'll see that this thing returns an XDocument. Now, in C# you have to write code somewhat like this to create the XML you want to work with. Now, the XDocument class makes it much easier than working with the XML document, that is the XML DOM, because the XDocument class allows you to write code that actually looks like the XML you're creating. I won't compare this to the corresponding XML DOM code, but believe me, if you've done that, you know this is a lot easier. We'll return a new XDocument, and then in the constructor, we can pass as many things as we need. I have a declaration, a comment, and an element within my XDocument. Now, the declaration is that standard XML declaration at the top. We have an XComment. This simple data represents food items, blah, blah, blah. And now down here we have an XElement, which contains a root element for this XML stream called grocery store. And within there, we have another XElement named departments. So you can see that the grocery store element contains a departments element. The departments element contains 2 departments, each named department with an attribute that identifies which department it is. Here we have a department named breads. Down below, we have a department named fruits. Within the department named breads, we have an element with an attribute whose ID value is B1, and an element whose name is Wonder Bread, price $1.29, and it has an element with no value called new. Another element called item with an attribute of ID whose value is B2, and so on. So you can see that we here create the XML that we need just by embedding nested XElement, XAttribute, and so on instances. Now I do want to point out, before we go any farther, let me stop running here, that the C# code editor makes this really easy. So let me start typing this again. If I come up here and say return new XDocument, and I go to the next line, notice they indent for me. New XComment. Here's a comment. And then I need another element with another node within this document. It indents correctly. Let's put an XElement here. And say within that element, I want other elements. So I come here and they indent it correctly. And when I put the closing, they get that right as well. So let's go up a bit and come put something in here. I guess we need actually a couple more here, at least one more anyway. There we are. We come up here and start putting things inside this element. Let's say new X attribute, whose name is X and its value is Y. And it's all indented for you. It makes it really easy to create XML content in your code. I have to mention that in Visual Basic you just type the XML and drop it right in, but this is pretty close. Using the X document, X declaration, X comment, and so on makes it pretty easy to generate XML content on the fly in your code. Let's step into this again. This time I'll step over the create document because it just returns back to us the XML document that we need, and you can even see the XML laid out for us here when I hover over that doc variable. All right, now here's what I'd like to do. I would like to iterate through all the descendants of the document whose name is item. This should give us all the items in the grocery store, where the item.parent.attribute has an attribute named name, whose value is breads. So I want to find all the items in the department named breads. I want to select that item. This should return back for me all of the items in the breads department. There we go. And we should end up with now, let's see what we got. Here we got Wonder Bread, and we're going to display the entire item. And this one is, I think, a blueberry muffin. There we are, a blueberry muffin. Now we're done. Okay, well now what if we want to retrieve the value of each one? That would just be the text inside of it. Okay, so here we retrieve that text. And what is the value of each one? Well, it's Wonder Bread 129. Why is that? Because when you retrieve the value, you get the text of all the nodes inside the node you're looking at. And that item included a name element and a price element. So we're getting both of those values concatenated together. Okay, well we can go farther than that, because we can also, for each item in our collection of items, print out the value of the element whose name is name and the element whose name is price. And we get those individually. When I run this full speed, here you'll see, here's the XML we created. Looks like that. I displayed that in the output as well. Here are the two elements we found when we displayed the actual return value in our collection. That's exactly what you'd expect. Here's what you get when you retrieve the value property of each element. And here's what you get when you retrieve the sub-elements. Here's the name and the price, name and price, in a nicely formatted output. So you can see that you have lots of flexibility when you use LINQ to XML in terms of retrieving the data you want. We could spend days covering all the possibilities, the various axes involved in querying XML data. I just wanted to prove that you can use the XDocument class and its friends to create XML, and then you can use LINQ over that XML using methods like descendants or parent and attribute to retrieve anything you need from the resulting query results. You can use LINQ queries to transform XML in a more straightforward manner than, well, anything would be more straightforward than using XSL transforms as far as I'm concerned. To do this, you combine new XElement instances with LINQ over XML query. As you'll see, you can, in your select clause, output whatever you want from this query. It's a pretty interesting technique. To make it easier, Visual Basic also provides embedded transformations using angle bracket %equals, just like ASP.NET does, that is replaceable tokens within the output. Let's look at an example that demonstrates how you can transform XML using LINQ in language-specific features. Starting with the output from the last example, note that we have items scattered about in various departments. I might want to take this data, query it, and get a list of all the items in one place where attributes define the name and the price of each item in the grocery store. To do that, I need to perform a transformation, and although I could use XSL transforms to do this, it's hard to do. This is pretty simple. First thing we do is create the document again, so we have our XML content. That could obviously come from a file, from a web service, from wherever you get XML. And now I'd like to retrieve a list of all the items. To do that, I'll say from item, that's our iterator, in doc.descendants named item. That'll look at any level below the current doc level for an item whose name is item and hand it back to us in a collection. So now items has in it a number of different things. It's got, well, you can't see them there, but we do have, there we are, 3 elements we'd like to work with. I need to transform these elements into elements named item with attributes for name and price. Here's how we're going to do it. Remember that a select clause in a LINQ query defines the output of that query, and the from clause defines the input for the query. So I'm just going to take here, create a new X element named items, and the content of that X element will be all this stuff from the query. Well, what is the stuff from the query? From item, that's our iterator. In items, that's our collection of all the different items. The select statement says what to do for each item. What do? We create a new X element named item. Within that X element, we have an attribute named item name. Here's the value. And an attribute named price. And here's the value. And this code implicitly loops through all the items in this collection and outputs this data for each item. It's a pretty heady concept. It gives you the flexibility to transform any data from any format to any other format, using LINQ to implicitly iterate through the input, using the select statement to define the output of your LINQ query. If we run this full speed, you'll see again, here's our input XML just like before, and here is our transformed content. We have a collection named items. Each item within it is named item, and there's an item name and a price attribute for each item in our grocery store. So we used a LINQ query to iterate through the input data, get us a collection of all the items, and transform them to this new format. It's a lot easier than using XSL transforms, if you ask me. Although we've scratched the surface of LINQ, you'll want to dig a little deeper so you can use it with full features in your applications. Visual Studio's documentation has excellent LINQ coverage. It's a great place to start. You'll also find articles in the June 2007 issue of MSDN Magazine that introduce LINQ very nicely. So take a moment to look at the articles in that issue. You can find them online at this link. There are also 101 LINQ samples that really cover a lot of the things you'd want to do with LINQ on Microsoft's site. I'm not showing the address here because they move from month to month, but if you go on the web and search for 101 LINQ samples, you'll find them both in VB and C#, so you can compare the two if you like. In any case, LINQ's a very exciting new feature, and you'll need to dig a little deeper to take full use of it in your applications.